Welcome to the part 8 Oops the realistic run, which is part of module 6 classes and oops. And this is very important part because here I'm gonna put everything, all concepts, whatever we have learned so far, and to work it with one realistic example. It will be a most exciting and fascinating session. So just sit back and watch it. So it's time to put bits and pieces together and make a ever beautiful and marvelous yet meaningful artifact. As I am talking about Python classes and oops only. You don't need to worry, dude. So let us make one more example, but this time we will write code for that in a systematic and sequential manner using all the concepts whatever we have learned in oops module. Okay, so now what is our agenda? We are going to build a set of classes that do something more concrete, such as recording and processing information about pupil. As you will see, what we call instances and classes in Python programming can often serve the same role as records and programs in more traditional terms. Specifically, in this video, we are going to code two classes. Just note down, kindly note down. One, person. Person is a class that creates and processes information about people. Two, manager. Manager is a customization of person that modifies inherited behavior. In addition to that, along the way, we will make instances of both classes and test out their functionality. When we are done, I will show you a nice example use case for classes. We will store our instances in a shell object oriented database to make them permanent. That way, you can use this code as a template for fleshing out a full-blown personal database written entirely in Python. I hope you're getting what I'm speaking. That's fine. So the main intention to put this is to explore real oops. What is a real object oriented program? How do we use this in industry? So how much it is helpful when we are working. So explore real oops is to demonstrate all of the main ideas in Python's OOP model. Despite its syntax details, Python's class system really is largely just a matter of searching for an attribute in a tree of objects, along with a special first argument for functions. Okay, dude, enough is enough. So much for the design phase. Let's actually move on to implementation. Our first task is to start coding the main class persons. Okay, we will begin with step 1, that is making instance. So here our first task is to start coding the main class. What is the main class? I have told you, kindly recollect it. What I have told you, just repeat. It is person. Yes, you're right. It's a person. Okay. Let us name our module file as person.py. Okay. Actually, of course, you have to write everything in a file so that after that it can be reused. It can be reused. So we will write in a file and we'll name it as person.py and our class, and we'll write our classes and then blueprint within that file. So now first we'll make the class. We will use a class statement, and then name of the class colon. That's it. Okay, so after making the class, the first thing we want to do with our person class is the record basic information about pupil, uh, to fill out record fields. If you will, of course, these are known as instance object attributes in Python speak, and they generally are created by assignment of self attributes in class method function. Okay, the normal way to give instance attributes their first values is to assign them to self in the init constructor method, which contains code run automatically by Python each time an instance is created. So we have added a name statement, that's the class statement, and we have created a person class. Then we have to build a roadmap or a blueprint to record the information of the pupil. For that, what we have to do, we have to use init constructor. So we have used it, and inside that we have to use self dot whatever the parameters we have given, so that these values will be assigned to the other instances. That's what we have said before. So let's add those self dot name, and then the remaining follows the same. Now notice the argument names appear twice here on top. Here you see here self dot name is equals to name equals to name, job is equals to job, pay is equals to pay. This code might seem a bit redundant at first sight, but actually it is not. The job argument, let us take this example. The job argument, for example, is a local variable in the scope of the init function. Okay, these are basically parameters, and it is a local variable of init function. But the self dot job is an attribute of the instance, that is the implied subject of the method call. So there are two different variables which happen to have the same name. By assigning the job local to the self dot job attribute with self dot job is equals to job. So we have saved the passed in job for the instance for later use. I hope I have been explaining the same thing throughout the module 6 classes and loops. At least now it should be clear. Okay, and then and finally, one more augmentation to our constructor is we can provide defaults to some of its arguments. So they need not be provided in cases where their values aren't available or useful. To demonstrate that, let's make the job argument optional. Okay, because all people may not work, so that's why we'll set a job argument to the default. So it will be default to the none. You see here, job argument defaulted to none, and pay also 0. That's fine. And then meaning the person being created is not employed. If job defaults to none, we will probably want to default pay to 0, because if he doesn't have job, then how can he get pay? How can he get B paid. Okay. Uh, mm. So we will probably want to default pay to 0 also to for consistency. That's fine. Then what this code means is that we will need to pass in a name when making persons, but job and pay are now optional. They will default to none and 0 if omitted. So I think these first two steps are clear. Now I will move on to third task in making an instance. That is add incremental self-test code. Basically, it is not part of making an instance, but it is vital to know before you work with oops, before you creating a huge amount of classes, before you creating a blueprints, you should know how to add this incremental self-test code. So this is like testing as you go. As we probably begun to appreciate already, programming in Python is really a matter of incremental prototyping. You write some code, test it, write more code, test again, and so on, so forth. So that's what we call it as a testing as you go or incremental self-test code. Because Python provides both an interactive session and a nearly immediate turnaround after code changes. It's more natural to test, so you go than to write a huge amount of code to test all at once. Now, for that, what we can do? How can we make this possible? For that, what we have to do is you have to use the code two ways. I will tell you what are those two ways. Each module can be used either as a script. One way is script or module which will be imported. The second way is as a module. Whatever file we are writing, for example, person.py is the file we will be writing, and this file can be either used as a script. Script means you'll just run that script there and you'll get the result. That is one way. The second way is you import that file and then you access only items or names which are required. So it should not give, when you import, it should not give any result. So these are the two ways of using your file. Now, if you ever decide to import the class in this file in order to use it somewhere else, we will see the output of its test code, because thus far whatever we have written now, if you add self.name, after that if you create an object and then if you call, obviously you will get it. So that's the reason. So we have to be very careful. It should not, your module, when your file imported as a module, it should not show any result. It should only provide an access to the namespace. Now for that, what we'll do is, so it would be better to arrange to run the test statements at the bottom only when the file is run for testing, not when the file is imported. So that's what the module trailing double underscore name leading double underscore check is designed for. As you go, as you learned in the previous videos of the course, so you just revisit our previous videos, and we have discussed about this before also, but here we will be discussing with best with a proper example and more concretely. So this is what we will do when run for testing only. And if you import this file, it won't show any result, because you have put whatever items you want to set, you want test inside the if block, inside the if compound block. So when you run test, then only these items will be run. If you import this file, these items won't be run because it will only give access to this. Okay, I hope you got that what is incremental self coder test as you go. So if name double is equals to main string is very important. From now onwards you have to use this. Okay, just remember this. Anyway, I'll show you while coding in Jupyter notebook. You don't need to worry, but initially you just focus on theoretical aspect, then we will enter into practical aspect. So now we will get into Jupyter notebook. Here it is. Making an instance is our first step. That's what we have discussed in our slide, some of the theory concepts. Now in that, our first subtask is make your main class. Let's make it. Class statement, name of the class, and then colon. Your class is ready. Now okay, so this is better. Making an instance. So now what we'll do is we name the class, but we do not know how does it feel like, how does it look like. We do not know what person class mean. So now we will design our class. We will lay out the attributes and actions in a simple layman language. We will make one category with set of rules. Let me execute this. So for that I will use constructors. Coding constructor, that is the second subtask. So I have made a class, and then in it I have to define the shape and give the features. So I will do that. Now to give state or attribute to the class, what we need is a constructor. As name reflects, it builds a plan or blueprint of attributes of a class. So this is what we'll add a record field initialization. Basically init function is initialization. This is a record field initialization. It took 3 parameters, and then each parameter is assigned to another variable which is self.name. It is a instance attribute. So we have discussed this is not a redundancy. There is a specific purpose to it. That's the reason we are doing this. So we have built our person with attributes. He will have a name. Person category will have name, job, and pay. Now the job argument, for example, is a local variable. It's very clear. We have discussed before also in functions. We have discussed in functions part 2 scopes. We have discussed about the various scopes, local variable, non-local variable, global scope, and everything. You just go back and visit those videos, and then you can watch it here if you have any doubt. So now the job argument, for example, is a local variable here in the scope of the init function, but self.job is an attribute of the instance. There are two different variables which happen to have the same name. By assigning the job local to the self.job attribute with self.job is equal to job, we save the passed in job on the instance for later use. I have discussed this topic in our slide, so that's why I'm not explaining here. I hope you got what I'm trying to convey. Then our constructor is ready. So now I want to add some defaults to it. So if job defaults to none, we will probably want to default pay to 0 just for the consistency, because if the one who doesn't have job, how can he have pay? So here job and pay are zeros. Job is none object and pay is 0. So I'll execute this. With this code, what this code means is that we will need to pass in a name when making person, but job and pay are now optional. Now you don't need to give if you don't want. If you don't give those arguments, by default it will be taken as none and 0. So now the third subtask in making an instance is incremental self-test code. So why we are putting here? Because see, the logic is simple. Whenever you are writing a big file, in that time you will have some doubts. So while writing your file, you will do the testing, but at the end this file should be used for somebody will import this file and then he will use it in his program. So if he wants to use it, and whatever file you have written and whatever test you have written, if they also got executed when they import, then what is the point? So it is not good. So that's the reason we will add a different function, a different name, so that we can make both possible. You can do it self-testing here, and if somebody imports that file, it only gives access to the names. It will not execute these tests. Let's see how can we do. So the first step for us is, I will go to the VS Code, and then in that VS Code I will write the same code, whatever code we have written here. Whatever code we have written there, I will just copy and paste it here. Everything remains same. Okay. So but here what I have done is, I have created an instance. I have instance or object. Create instances or object of person class. First object is Madh, second one is Kesh. So these are the one. Now while I just want to test this, so that's the reason I have added this test. I just want to print name of the Madh object and pay of the Madh object, and then name of the Kesh object and pay of the Kesh object. So I have this two tests have written, just whether my classes and object program is working properly or not. So basically I executed, it's working properly. Now my file is ready. So let's see what will happen. So add incremental self test code, and the first one is without this name function. I have not included any name function in it. So these are the tests I have written while writing my program, and it is done. I have closed it, I have saved it. Now it is open to anybody to import and work it. Let's see what will happen if I import. So when I import mod1, that's the name of the file, it is automatically giving the test results. Of course we'll get the namespace access. But the thing what's happening here is, this is our namespace access. It consists of person class, and then Kesh and Madh are the attributes. But that is fine. That is not an issue. Kesh and Madh are our objects inside the file. But that is not an issue. But whenever I import, these things are also being executed. But this is not the way. We should not give the results when somebody is importing your file. So how can we stop doing this? So how can we prevent it? How can we prevent this to happen? So we have one hack, or we have one item to save us. That is name function. Trailing double underscore name, leading double underscore. I simply call it as a name function. Okay. So what we can do with this, now here in this case, we will use name function so that we can write our test cases while developing the program, and at the same time when someone calls that module, this testing is not visible at all to that person, whoever is importing that. Let's see how can we do that. Let me go back to my root folder and create a one more file. The name of the file is mod underscore name.py. So here what I have done is class, and then I have constructed the attributes of the class. It's a layout or blueprint. So with this, my class is ready. So now I want to test it. So this part, whichever I have marked, that is the only piece of code. That's the only piece of code or variables that I want to expose it to the third person who is importing my file. Okay. So now the remaining thing, these all, whatever whatever things are here, these are things I want to use it for the testing. I just want to test whether this piece of code is working properly or not, because if I write the bigger and bigger code, I will have more tests. So first one is I have created an object math, and second one is I have created another object cache, and then I just want to check whether I am able to fetch the instance attributes such as name and pay. So let me execute here. Here you got some name cache is not defined. Okay, these are all not defined here. That's fine. Now I'll save it, and then I'll go back to our Jupyter notebook. What is the name of the file? Mod underscore name. So this is how we import. Let me import that. No issue in imports. So let me now just compare with the mod 1. It did not show any testing output result. If you see mod 1, when you import mod 1, it has given a test results, whatever code I have written to test that file. But here in mod name, in this file, it hasn't given any test results. It did not show any test output results. So that is what we want. Now if you see the namespace, you have only person. So but without name variable, we got the object names also, because the object names that we have created for the testing, I don't want them to expose it to the third person who wants to use my module. Okay, so that's done. So that's how we can separate a test as well as module import from. And now step 2, adding behavior methods. Everything looks good so far at this point. Our class is essentially a record factory. It creates and fills out fields of records. Here I would like to add 2 behaviors to our main class person. So yes, 2 behaviors to our main class person. First one is to extract the last name from our object by splitting on spaces and indexing. First one. Second is to give a pair is. Okay, I will first write this one, and then we'll go for the second one. So thus far the code remains same. Now I want to add methods to it. First one is last name, and then self dot name obviously comes into the picture, because that's why we have this is instance attribute, so we can directly use that here and use a split method of that string object, and we want to split it at this point, so as it consists of 2, okay, from -1 the second side. Now the second one is to give a pay raise by updating its pay field, that is by changing the state information in place with an assignment. However, what we really want to do here is employ a software design concept known as encapsulation. Encapsulation. The idea with encapsulation is to wrap up operation logic behind the interfaces such that each operation coded only once in our program. That way, if our needs change in future, there is just one copy to update. Moreover, we are free to change the single copy's internals almost arbitrarily without breaking the code that uses it. So here again we will add self.pay. Here you can see this self.pay can get it from here, and is equals to int self dot, we just want to update that self.pay, whatever self.pay, whatever pay he had, and you just multiply with the percentage. So then your pay rise based on percentage argument that give to that method, it will increase your pay. So that's what we wanted to code here. So again we'll use name and then main to separate the testing and then module import. Okay, so now what we'll do is we'll go back to the Jupyter notebook and add a behavior methods to our main code. So the second stage or second step of writing OOPS object oriented programming script is adding behavior methods. So now before adding the behavior method, I want you to let know that we have two types. We have two ways. One is either you hard code the operations or you just write a method and then use it for all instances. Let's see if you hard code it, what is going to happen. This is called hard coded operations. What will happen if you hard code? So we will hard code the same here first. Again the class and then their construction remains same, and we have added if name double is equals to main string, so that we can separate the testing and then import. So we have created two objects or two instances. One is Madh, which takes default job and default pay, and Kesh, he has his own job designation and then his own pay. Now we will print the attributes of both the objects name and pay, but what we want to look here is we want to hard code the required behaviors, whatever behaviors we have discussed. So these are the two behaviors or methods we want to add. One is last name and give rise. So now let's see if we add them, if you hard code it, what is the loss here. So to hard code it, what we can do is math.name. This will give you that name of the math object. Then you use split and then split of -1 is your index position. And similarly cache.pay and augmented assignment operation and then 1.10, the addition of percentage. So you will get it. So this is in this way. If you want to do it for the cache, if you want to do it for some other object, if you want to do it for some other object, every time you have to write it manually. So just imagine if you want to calculate for 1500 objects or 1000 objects, then your code, your file will become too much. It will become huge, humongous. So that is the reason, in spite of hard coding, we will write a method. Basically, coding methods, it is also called as encapsulation. Coding a method will, because of coding a method, it benefits a lot. First logic is because this encapsulation is nothing but we are wrapping up a logic inside a certain file, certain function. That is one. Because of this, we will code this once in our program and we can use thousand times, lakhs of times. One benefit. Second, the benefit of encapsulation. The second is, if you need any changes, just go directly into that piece of code and change it. You don't need to worry. And and there are a lot of other things, so you don't need to. And one variable, example x, a variable x can be used in different methods, because each method is encapsulated and each method is separated from other. That's the benefit we have, because the x variable is local to every method. That is what we call as encapsulation. I hope you got it. This is very important topic to understand. That's why I'm spending more time to explain this. So now we will do add methods to encapsulate operations for maintainability. Now we have done the same thing. We will add methods using encapsulation design concept. Basically, this is software engineering design concept. It is not just a Python concept, it is software engineering design concept. Now we have built our our class, and then our methods here. So this is one encapsulation. This is the second method, is in different capsule. These are the two capsules which are separated by encapsulation. So these are the two methods. Now for the incremental self test, if you want to test this code here, you can do it here only. Here, so here I have created object 1 and then second object. Now as I'm started the testing, so printing the here, and then another two here I started. I used first method is last name, cache dot last name, second method, and one more method is give rise. These are the two methods I have used, and these are the output. This is for the testing, and I can use the same file to import, and it will not expose the test results to the programmer who has imported this. So the below, which are the class attributes, are this, and class methods are this. Basically, last name is Madhava, last oh sorry other last other last name is Keshava, and after the pay rise, the salary has become this much. So to conclude the step 2, that is adding behavior methods, turning hard coded operations into methods enables them to be applied to any instance of the class, not just those they have been hard coded to process. This concept of encapsulation helps in keeping a single copy of that method, so we are free to change the single copy's internal almost arbitrarily without breaking the code. If you want this in future at any time. Now we will move on to step 3, that is operator overloading. At this point, we have a fairly full featured class that generates and initializes instances. along with two new bits of behavior for processing instances in the form of methods. Basically, they are pairize and last name methods. So far, so good. I hope you guys are enjoying it. As it stands, though testing is still a bit less convenient that it needs to be to raise our objects, we have to manually fetch and print individual attributes. Example, Charan.name or Hari.pay or something else. It would be nice if displaying an instance all at once actually gave us some useful information. Unfortunately, the problem here is the default the problem here is the default display format for an instance object isn't very good. It displays the object's class name and address in memory, which is essentially useless in Python except as a unique identifier. So now what is the option? So basically, before I am giving a solution to you, we have discussed operator overloading in our previous videos of this module. So kindly watch those videos before you watching here, because there I have explained it very thoroughly so that it will be very clear. I am using one of the concept from that video here so that I can customize my display format so that while testing it would be easy to understand. Because okay, so now, so I have this piece of code you might have remembered because I have been writing this code again and again. So now to this piece of code I am going to add one more method which actually customizes the default display. Okay, so that method is the now to customize our display method we have to overload existing method. So we will do it using trailing double underscore str leading double underscore method. Now str allows us to tap into a specific operations and provide specialized behavior when our objects are used in those contexts. Let us put this into code. This is how we write. Def, that's defined, and method is our trailing double underscore str leading double underscore, and then inside that we'll put self. Now what do you want to return? The string is name of the class, that is person, and then two curly braces which are placeholders for the variables, and then the format is self.name is one instance attribute and self.pay another instance attribute. So now when I print an object, I want to get this type, like it is a person class, and then whatever that object consists of, name of that object and then pay of that object. So that's how I wanted to customize the display format for the object print. As usual, we use trailing double underscore name is equals to main string object to test the code in place. And let's see what is the output we get. See, this is how we get the output. This is what we want. This is how we have customized our object. This is a second object. Okay. Now we will go to the Jupyter notebook and we'll see. This is our operator overloading. Step 3. We move to step 3, that's operator overloading. We will code. So now let us, before looking into how to customize the display, we will see how the default display prints our object. Okay, this is our piece of code. Now we have added methods using encapsulation design concept that, but now this piece of code we have been discussing for 5 to 6 times by now. And then here I have two methods in it. These are attributes, these are methods, and now I just want to check how it shows. I just want to show you one thing, that is print object. I have two objects. See, I have created two objects here. One is Madh, second one is Kesha. Okay, now this is what you have to focus for default display behavior. I want to print that object Madh and print cache. So what you are getting is main dot person object at memory location with a hexadecimal number. For the second also main dot person object at memory location. So basically there is no difference. There is no difference. See, it is just giving a memory location. It will be used as a unique identifier. But what can you make out when you are testing? Which is what and what does this consist of? Do you know anything? Can you make out? Can you make it? So it's difficult to understand what it is. So that is the reason. This is the default. This is the default display of print object. So now what I want to do is I just want to customize display with trailing double underscore str leading double underscore method. Basically this concept is called operator overloading. If you do not know, please watch my videos. So then we will use this str. Basically str allow us to tap into specific operations and provide specialized behavior when our objects are used in those contexts. Now let us put this into code. The following extends our class to give a custom display. That's what we want. That lists attributes when our class's instances are displayed as a whole. Instead of relying on the less useful default display, we can make our own customized display, which makes more sense. So now this is our complete piece of code. You can see this. So here we know till this part. Okay, these are initial attributes and then methods. Then we will write this operator overloading method here. So what I have done here is I have used trailing double underscore str leading double underscore method and then self, that is by default. So now return this string format. What is that? What is the name of the class? Person, and then curly braces dot format and then attributes of that object or of that instance. Now let us see. Let's execute this and we'll see. See, I am calling those. So here it is. 1 minute. I just want to go move up. Yeah. This is one object. This is another object. Print Madh is one object, print cache is another object. I just want to print both and we'll see what we get. So when I print, okay, or else I'll execute this and I have opened one more tab. So in that I will print Madh. See, person class and attributes are, his name is Sri Madhava and his pay is 0. And similarly, I will print one more object, that is cache. Let's see. Cache person class, Hari Keshava is his name and pay is huge amount. So that's how we can customize our display. So I hope you got the gist of what operator overloading is and how it can be used to overload the default behaviors. And now we will move on to step 4, customizing behavior by subclassing. At this moment, our class captures much of the OOP machinery in Python. It makes instances, provides behavior in methods, and even does a bit of operator overloading. Right? Yes or no? Just reply me. You just answer my question, yes? Ah, okay, fine, fine. So, the only major OOP concept it does not yet capture is customization by inheritance. In some sense, we are already doing inheritance because instances inherit methods from their classes to demonstrate the real power of object-oriented program. Though we need to define a superclass or subclass a relationship that allows us to extend our software and replace bits of inherited behavior. That's the main idea behind the OOP is, after all, by fostering a coding model based upon customization of work already done, it can be dramatically cut development time. Okay, now coding subclasses. This code means, so we have added a manager class, manager subclass, and it inherits from person. It inherits from person. Whatever code that we have written now, this code means that we are defining a new class named manager, which inherits from person class and may add customization to the superclass person. For sake of argument, let us assume that when a manager gets a rise, it receives the passed in percentage as usual, but also gets an extra bonus. That defaults to 10 percentage. For instance, if a manager's rise is specified as 10 percentage, it will get 20 percentage. For that, what I have to do, I have to add a bonus of 0.10. That's what I have done. So as this parameter is specific to customized give rise method of manager subclass. So that's the reason here you don't need to use a self dot because it is specific to this one only. Now I'll add back this to the give rise instance attribute. Now with this, now after creating a subclass and adding a customized method, if you call the same method for two instances of person and one instance of manager, irrespective of the instance type, Python runs the appropriate give rise to all three instances. This is called polymorphism in OOPS. We have discussed polymorphism in Python, but the polymorphism in OOPS is this. Irrespective of the instance type, Python runs the appropriate give rise to all three instances. This kind of behavior is called as a polymorphism. In simple terms, what give rise method does depends on what you did it or give it to the code before. This is what called as a polymorphism. Now let's call those instances and then apply this method to that, and we'll see what we are going to get. So again we use if trailing underscore double underscore name leading double underscore is equals to main string object. Then I have created first object Charan, and second object is Hari, and then third object or third instance which is of manager class. The initial two are of person class and third one is manager class. I have created that. Now let's print all three. First, for object in this thing. So create give rise. So object and give rise. So then what we got is for all three manager, for person we got 0, and for Surya we got 0, and for Hare Krishna we got this much, and for Trikala it belongs to manager class. It got a higher one based on the parameters that we have given. So now one more topic I just want to discuss is I just want you to let know the exact difference between these things. Before we enter into the next step, let us understand the subtle differences between the terms inherit, customize, extend. Extend. In general, classes can inherit, customize or extend code in superclasses. For example, although we are focused on customization here, we can also add unique methods to manager subclass that are not present in the person superclass. So here, that's what I have done. So here I have added JD. JD, this is a new method which is specific to manager subclass. So that's the reason this is called extend. And if you do any modification to the existing method, that's called customization. If you inherit the complete class, it's called inheritation or inherit. Now let's jump into the Jupyter notebook and we'll code the same aspects in that. So now uh, as we are using more amount of concepts of whoops, the code also becoming huge and huger. So please kindly bear with me. Don't be afraid of this code. It is nothing but same code. We are copying it and then we are adding more concepts to it. That's it. You just take it simple. It's easy. So now customizing the behavior by subclassing. First task in this is make a subclass manager and add customized behavior to that subclass manager. Okay. First task, what we'll do here, this part is normal, and then it also has two methods in it. In addition to that, we have added operator overloading. So this piece of code we have done in our previous step only. Now in addition to this piece of code, I want to code a subclass. A subclass. What is that subclass? Subclass manager inherits everything from main class person. However, it will have its own give rise method. This is also known as just a minute, customization. Now let me come down a bit. So let's add that piece of code, class, and then its manager subclass, and it inherits from person. So basically here inheritation part is done. Then we will customize our one of the method in the class, that is give rise. As we have discussed earlier, as we assume that manager gets a rise, just 10 percentage 10 percentage additional bonus he gets then compared to the person class. So that's what we have added here. In addition to the percentage, we have added a default bonus, that is 0.10, and then this part is done. Now with that our code ends. Now whatever we do below, these are testing. So this is all testing. I just want to test my code whether it is working properly or not. So for that, what I have done, I have created my first object, that is math, and then second object is cache. These are my two objects. Then I want to print those two objects, print math and cache, and then I just want to get the methods last name and then give rise both. So these are the attributes and methods of class, main class. So as we have written a subclass, so first we'll create the subclass object, that is wish is our subclass object. And then in addition to that, let's print all objects together. So let me execute this and then see, this is my output. The below which are class or instance objects. So these are class or instance, main person class or instance objects, and these are also related to that, whereas this is a testing subclass. Here it is, Vishnu is our subclass, and person, and this class name should change. So that's how we add a subclass to our function. So with that, one task is done. Then the next subtask in it is polymorphism in action. That polymorphism. So to make this acquisition of inherited behavior even more striking, we can add following code at the end of our file. Basically, this is customization. We carry the same file, but in class manager, what we have done is, in addition to the existing given arrays, we have customized this. And then let's compare each object. We have three objects, math, cache, and a manager. Total 3 objects. Now, so as we have 3 objects, and then we'll call 3 objects and we'll check pairwise of each one. If you see, pairwise of first one is 0, pairwise of second one is normal, that's 10%, but pairwise of third one is with bonus, it's 20%. So this is what we call it as a polymorphism. So this is what I am talking about, and this is nothing but polymorphism. In the added code, object is either a person or a manager. So these two classes, and Python runs the appropriate give rise automatically. Our original version in person for both objects, that is math and cache, and our customized version in manager, that is wish. And trace the method calls yourself to see how Python selects the right give rise method for each object. So this kind of behavior of Python is known as polymorphism. Then we will move on to the third subtask of step 4, that is inherit. That's the comparison between inheritation, customization, and extension. That is inherit versus customize versus extend. So in fact, classes can even be more flexible than our example implies. In general, classes can inherit, customize, or extend existing code in superclass. For example, you see this example. We will add methods using encapsulation design concept. So thus far it is remains same. So we have added subclass. Here we will look. So manager class will inherit from the person class. This is called inherited. This inheritation is known as inheritation from super or main class. And then second one is give rise uses a bonus and one additional parameter. So this type of specific implementation of method to this subclass is called customization of the inherited method, that is give rise. And if you see the third one here, finally we have added a completely new method which was not there with the person class. So that is experience method. So this is extend by making the absolutely new method in this class. So this is the difference between inherit versus customize versus experience. Here you can see all three together. So now oops ends there, and then what we have is testing all three together. So what we'll do, we will call last name give rise and then experience, because experience is completely, it is specific to the manager class only. So we can call that, and then we can see. So when I call wish dot experience and gave the two arguments inside it, then it gave me total experience of Mahavishnu is 12 years. Okay. So then now we will move on to step 5, customizing constructors 2. So our code works as it is, but if you study the current version closely, you may struck by something a bit odd. It seems pointless to have to provide a manager. So manager job name for manager again. See, actually for manager subclass, when we create an object, we are providing mgr. So that's what I'm saying. So it seems pointless to have to provide mgr value, mgr job name for manager objects when we create them. This is already implied by the class itself. It would be better if we could somehow fill in this value automatically when a manager is made. For this to accomplish, we need to customize the constructor logic for managers subclass in such a way as to provide a job name automatically. In terms of code, we have to redefine an init method in manager that provides the main mgr string for us. So let's do it. See, thus far the code remains same, but here we have to do a little bit of modification for the subclass, that's class manager. So this is our class manager, it inherits from person, and then after that we will have our it will have its own or customized constructor, that is it will have only two, that is name and pay parameters, and also it, after the colon we have to put person dot init. So basically we are taking the person class constructor and we are customizing the one of the parameter in it, that is job. So in job parameter we gave mgr, that's the manager job. So then with that we will have our own customized constructor for the manager subclass. So and we will also define give rise, that's also customized method. Then let's try to code it and let's execute it and we'll see. See Charan, This is our first object, then Hari is second object. These are class objects, that person class objects. Then we have to write attributes as well as give rise method to both of it. Then this black color one are manager class. So Shiva is manager class object, and Shiva dot give rise will give you a different value, and then Shiva dot last name, and then print the Shiva object. This object belongs to manager subclass, and this object belongs to person subclass. If you see manager constructor here in between, you don't need to give job anymore, because Trikala and the salary pay, that's it. Job by default it takes it as a MGR. That's what customizing the constructor. So if you take output, this is what we get. And so with this we have actually customized our constructor. Let's see how this works when we put it in practice. So the first step the first task in step 5 is we have coded the new manager and constructor and changed the call that creates a wish to not pass in the MGR job name. Wish is wish is our manager subclass method. Okay, the first task is to customize the uh, subclass or manager class constructor. So main class is this from here. That is our main class. Main class by and large will remain same. We are not going to change anything. And then we here from here the subclass starts and here it ends. In subclass, in addition to so in subclass, normally in previous sessions, what we have done, we have just inherited from the main class. But here we want to customize our constructor in such a way that as the job of the manager role itself is MGR, so you don't need to specifically have that parameter. By default, it should give. That's what we are expecting. For that, we have written, we are writing our own customized constructor for it. In that, name and pay are the only two parameters. So now, from now onwards, when you create an object, you have to give only two arguments, that is name and pay. You don't need to give manager. So manager will be taken automatically. We'll check whether it is possible or not. So now my manager subclass construction will take only two arguments. Those are name and pay. That's it. But we want to add MGR, that manager job role, to the our person class constructor. So that's why after the colon we have included person dot init. This is the person constructor. In that, in spite of job argument, we directly put it MGR. That means MGR is by default will stay for every instance that you created with manager subclass. And then give rise is our customized method and experience is our extended method. So with this we are done with creating classes. Now we will test that using a piece of code. So how do we test? First we will create Mad, a person class object, then Kesh, another person class object, then we will make Wish. This is manager class object. So if you see the constructor of both, in Kesh, a person class object, you have given three parameters, whereas Wish, a manager class object, you have given only two parameters. This is how we customize our constructor, because that init manager has its own init and it had made this possible. So this is what I want to talk here. And when we call those objects print Mad and print Kesh and print Wish. So person class 2, person and then Harikeshwa 2. But when it comes to Vishnu, you got 2 arguments. You see, Mahavishnu and 72,000. That's the pay, because we are able to customize our constructor using that. Now before writing thus far, we have almost covered all steps and major concepts of Python object oriented programming. Now it's time to put a complete a final form of code at one place, so that our final form of code will be ready for the use of other people. So now, but don't get excited. Before writing completed final form of program, let us make a one more module, a separate module, which code one general display class. Please pay attention to this. This is very important. We'll code one general display class, so that later the same display class can be used in our main program. Okay, come on, jump in for most exciting journey. Okay, this is a crazy one. I really like this tool. Let's make it. So coding a generic display tool. Let's code it. So what we will do is, for that we can put these interfaces to work in a superclass that displays accurate class names and formats all attributes of an instance of any class. Now for that, what we have to do is, we have to open a new file in our VS Code, and the name of the file is class tools.py. .py is our extension. Now it's a new independent module named class tools.py that implements just such a class, because trailing double underscore str leading double underscore print overload uses generic introspection tools. It will work on any instance regardless of its attribute set, and because of this is a class, it automatically becomes general formatting tool. Let us code a general formatting tool and implement it as a module in our object oriented programming system code, the complete main code. Okay, now see, class name is attribute display. Attribute display is the class name, attr display, and this is the and the first method in that is gather attributes, empty list, and self.dict is another, by default, another inbuilt method we have used here, and then append and put it in a proper format and return complete attributes. Then a second method in this class is trailing double underscore list. So basically we have only one method. Inside that we have string also. This gives a format. This overloads the print format, print default format. So now to test we will use some of these examples, and then after that this is how we get. So now we will go to the Visual Studio Code and we'll write that file. So this is that. The name of this file is class tools.py. Now the class of this name of that class is attr display, and basically what it does, doc string I have written. The doc string is, it provides an inheritable print overload method that displays instances with their class names and a name is equals to value pair for each attribute stored on the instance itself. So that's the purpose. We just want to use a general formatting tool or display formatting tool. So now it consists of one method that's gather attributes, and second one is a inbuilt that's a string method. It's an operator overloading. It is to get the proper formatting right. So once I create this file, I will save this and I'll try to import, and then I'll try to incorporate this module into my main code, complete full form of code. Let's see how it makes a difference in our code. So now the utility of this module is to display the instances with their class names and name equals to value pair for each attribute stored in the on the instance itself. So let's move ahead and let's put a complete piece of code here. After integration of class tools module into OOPS code, so our class's final form. Congratulations, you have written your complete OOPS code. Congrats, it's a big achievement. Tap your shoulder and enjoy the moment. Okay, now we'll put everything in place. Now our class's final form is, so as we want to use the display format, so what we'll do is we from class tools import attr display class, and then our person class will be inherited from this class. Why we are inheriting? We are inheriting display format. We are inheriting only display format, because if you have a proper display format, it is easy to test while writing a code. So that is the reason we are using this. But it is not main part of OOPS, but still this kind of concept makes writing OOPS easy. As a programmer, you should have these kind of tools in your toolbox. Now, the remaining thing remains same. It consists of this is our instance attributes, and then it will have two methods, that's last name and then give rise. These are for the class person class, and similarly we have a subclass that is manager, which inherits from person. Obviously manager as person inherits from attr display. So manager, it is a total a multi-level inheritance. This is a multi-level inheritance. If you do not know what is multi-level inheritance, I have made a video on inheritances with a real world example. Please go back and watch that video and then come back here. Okay. Then we have written a subclass, that's manager, and a customized person with special requirement. It will have its own constructor and a customized give rise method, and then an extended method if you want to include. So finally your complete piece of code is ready. So now you can do the testing by creating objects that are belongs to person as well as manager, and finally you can check it out. So now we will write our final full form of code in Jupyter Notebook. Okay, now to write a full form of code, what we need is we have to import a generic display tool this is nothing but a file that we have just written in VS Code. I will show you again. So this is the file class tools.py. This is the file just we have written. I want to import this file as CS. Now import class tools as CS. So no issue with the import operation. It's fantastic. Then we will see the namespace. What are there in that namespace? It consists of only one class, that is attr display. Rest all are built-in functions. So now we have worked with attr display. Okay. So now using that we will put our class a final form. We will bring all the bits and pieces together to make a meaningful program, and also we import class tools module that we have just written, and we will use it in our program, our complete piece of code. So I think, is it okay? Yes. Just give me a second. Yeah. Yeah. So now you can see the complete piece of code. I hope you're able to see. Yes. So what I have done here, the final compilation of all bits and pieces of together so far. Now the first step is import a class from class tools module. It is a general display tool. So from class tools import attr display class. So then what we'll do, the next step is person class inherits the main attributes, that main functionality, the display tool from attr display class. So that's why now our person is being inherited from attr display. Now again after that we have a constructor with instance attributes, and we have instance methods. Those are two. These are belongs to person class data, and then we have to code subclass, and we have to code subclass. Subclass here is a manager which inherits everything from main class. However, it will have its own constructor, a customized constructor, and it will have a customized method and an extended method. Our customized constructor is, it will have only two parameters, that is name and pay, whereas this has three: name, job, pay. So that's how we customized it. And then it has a customized give rise, because the manager gets bonus of 0.10%, sorry, 10% of additional bonus. So we have customized give rise. And finally experience is the one which we have added to this person. So with this we have completed a piece of OOPS code, in addition to the attribute attr display tool to format the complete display. Now let's see how does this changes our code viewing thing. So I'll zoom it so that it would be clear for you. One more. It's not getting to. Okay, it's taking time. Just give me 1 minute. Okay, so now if you see, now I think it's clear now. So the above is this part is the OOP code, and from here incremental self-test code. That's if name is equals to string main. This is the testing your code. So now what we have done is first generated mud person class instance, then cache and person class instance, which is manager class instance. Now what we'll do is In spite of checking everything, we will just we'll just print this object, only object, and we'll see what kind of display we will get it. Will it give a special format or will get a default format? Let's see. Let's check and see. Okay. I will create open one more cell, and then for that I'll execute this before. Okay. Okay, that's the mistake. Fine. I will change it. Don't mind. Yes, got it. Now let me get mud, that is instance object. You see, this is what I'm talking about. So this is the special format. This is how did we get it? By importing a display tool from outside. So that display tool also coded by me only, but still I'm just saying. So that's why we have used that display tool. Now I will add one more. That's print cache. See, person job creator. Then, sorry. Just. Then print wish. See, manager and job is equals to manager. So this is how it is actually formatting. Because of using this tool, you are able to format the display, or otherwise we would get some memory location of that object. So that is not much of use. So that's the reason we are using this. We have imported this tool. We have made this display tool, and we have imported and we have incorporated this in our final code. So with this, congratulations to everybody, whoever is following along with me. So we have completed Whoops. This is a brilliant achievement. Congrats. And now we will move on to step 6, which is storing objects in a database. Basically, it is not an integral part of this overall OOPS concept, basically, but it is very important to do this, or else whatever you do will not be stored anywhere. So that's the reason I have added this part also inside this. Actually, this complete 6 steps completes our object oriented programming system that we follow while working on big projects. So at this point, our work is almost complete. You can see the complete script. You can see the complete object-oriented program with the display tool also. Okay, and here you have a testing. Now we know we have a 2-module system that not only implements our original design goals for representing people. Those are 2. One is person, other one is manager, but also provides a general attribute display tool we can use in other programs in the future. So here you can see this is that display tool. By coding functions and classes in modules, we have ensured that they naturally support reuse. And by coding our software as classes, we have ensured that it naturally supports extension. Although our classes work as planned, though the objects they create are not real database records. Do you feel that or not? Yes, that is, if we kill Python, our instances will disappear. So they are transient objects in memory and are not stored in a more permanent medium like a file. So they won't be available in the future program units, whatever instances you are creating. So now what we can do? Now the question pops in our head is how to make them permanent. So we have a savior. we have our hero with a Python feature called object persistence. This feature is known as object persistence. Okay, so making objects live on after the program that creates them exists. As a final step in this tutorial, let's make our objects permanent using object persistence. Now, object persistence is implemented by three standard library modules available in every Python that are available in every Python. Those are the first one, the most important one is pickle. Pickle, what does it do? It serializes arbitrary Python objects to and from a string of bytes. The pickle module is a sort of super general object formatting and deformatting tool. Given a nearly arbitrary Python object in memory, it's clever enough to convert the object to a string of bytes, which it can use later to reconstruct the original object in memory. The pickle module can handle almost any object you can create. For say lists, dictionaries, nested combinations, they are often class instances. You say it will do. The next important one is DBM. What DBM does is it implements an access by key files system for storing whatever strings that were created from the objects using pickle. Now what we have is a shelf. So what shelf do? Shelf stores the strings under a key in a DBM file. When later loading, shell fetches the pickled string by key and recreates the original object in memory with pickle. The shell module provides an extra layer of structure that allows you to store pickled objects by key. So shell translate an object to its pickled string with pickle. So to put it in a simplest way, what pickle does is pickle picks the objects. It may be a list, a tuple, a dictionary, int, float, complex. It may be anything, a nested list. It picks that object and it will convert that object into string. Once it is done, then it will be taken by the shell. Then the shell comes into the picture. Shell shell takes the converted strings and stores it using a keyword in a DBM file in using a database management DBM module. And finally, when you call back the same object, shell comes into the picture. It will fetches that whichever location it is there, whichever location that object was stored in a string format, that will be fetched by the shell using key, and then it gives it back to the pickle. Then the pickle will convert that string object format back into the original format. If it is a list, it is a list. If it is a dict, it is a dict. So like that, the three coordinate together and they make this storage possible. In this, the DBM module, the purpose of DBM is to provide a system to store the data. And shelf is a storage space. It is a layer. In that layer, the converted objects strings can be stored. And then pickle is which is the starting point which converts the main object into strings. Now we will see how we can use it here. From person import just a code. Person is our file name. I will show it. Okay, just a minute. I have to open VS Code. Uh, Here it is. This is my complete piece of code. Whatever we have done till now, this is our complete piece of code. This is incremental test code. It is not important for us. From here, I'll just show everything in one piece of code. Let me bring it down. Yes. Now I think you are able to see the complete piece of code. Okay. Now let's see. So this is our complete piece of code. I have saved this piece of code in person.py. So now our module name will become a person and it consists of all those things whatever we have discussed so far. Now I have imported person class and then manager class from that. Then I have created Charan one object, Hari one object, Shiva one object. Three objects. Charan and Hari are person class objects. Shiva is the manager class object. Then let's import shell from the standard library. Then we will use db, that any variable name. You can take any name. In that using shell.open. Open is a method of shell, and then add this person db string. Now for object we'll use a for loop and then attach each thing to your shell and then close it. So this is how we do. So now we will go to the VS Code, Jupyter Notebook, and we'll see. Let's write a new script that throws objects of our classes into a shell, because shell is a storage space inside a DB, that's database. In our text editor, open a new file. We'll call it makedb.py. So I have written that file. Let me show it to you. Makedb.py, somewhere where it is. Here it is. So this is how I have, these are three objects I have created. I have been creating the same objects in each video, so I don't need to explain this again. And from person, I have imported both person and manager classes. Now I have imported shell. I use this for loop to store all three objects inside the shell, and I have closed the DB database. So with this, we saved our instances inside a database. Let me save it and then go back to the Jupyter Notebook. So storing objects on a shell database is done. Now let's import that file here so that we can see. Let me import. Yes, no issue. If this script has no output when run, it means it probably worked. We are not printing anything, just creating and storing objects. That's what happening. So when I import, no output, so it's working actually. So now you can look at the shells files if you want to, either from Windows Explorer or Python shell, but they are binary hash files, and most of their content makes little sense outside the context of the shell module. So now what we'll do is we will use some directory to view. So directory listing module files are present. Now we will import a module globe, and using that module we'll try to add. So this person is our main code file, that's oops code file. So with this we have made person.py and all these files. Now let's call person db.dir. Once you create that, you will get your database. Let me execute it. We'll see. So these are the three, because I'll just show you what objects I have created there. I have created the first object Mad. That's name of the first object is Sri Madhava Hare Krishna, and second one is Hari Keshava, and then Mahavishnu. These are all three objects I have created. So let me go back and see. These are all three objects: Sri Madhava, Hari Keshava, Mahavishnu. These are all three objects got saved. So now we will do small experiment. So basically now, just now we have imported this. That's why it may be working. Let's kill the Python. Let's stop it here and we'll close it. We'll close everything and we'll open it again and we'll see whether we are able to access that three instances or object or not. Let me close it here. From the, I'll kill from PowerShell and then I'll close it. I'll close it here. So I'll go back to the folder. Let me click shift plus mouse left, then show more option, window PowerShell, type Jupyter notebook, and it will open your HTML file using localhost and for 8888 port. Let me open that file. Let me come down. Here it is. I have reached. Let me execute this. Yes, without executing any cell on top, I directly executed this to get the %db. So it is actually stored. It is permanently stored inside that. So with that, we have actually reached to the end of the most important session, that is OOPS realistic run or OOPS with real life example. So this is what the final code looks like. I hope you enjoyed it. You watch this video again so that it will be very clear. So if your concepts are clear in OOPS with Python, you can work with any other language because OOPS by and large remains same, other than a bit of syntax varies. So that's why. So I hope you enjoyed this video. Just keep liking and keep subscribing and keep watching my videos and keep spreading to all of your friends so that everybody can watch and get benefit. Thank you and see you again in another session.